This is Mr. Champlin, and I'm going to do a couple examples of conservation of momentum problems for Chapter 4. The first problem is listed right there. A 20-gram ball of clay traveling east at 2 meters per second collides with a 30-gram ball of clay traveling 30 degrees south of west at 1 meter per second. What are the speed and direction of the resulting 50-gram blob of clay, if you ever wondered? So this is a good example of conservation momentum. So in terms of this situation, we have a ball of clay. I'll draw the picture. Here's my ball going east. Okay, and its velocity 2 initial. 2 meters per second. The other blob of clay is going 30 degrees south of west, so that would be in that direction. So I'm going to, here's west and here's south of west. So the other one going this way. This direction here is 30 degrees. And the velocity is VB, 1 meter per second. All right. And I guess from what the problem says, it's going to join together. It's kind of a collision that joins together, or non-elastic collision. So my guess is going to go in this direction because you have forward momentum, backward momentum. So vertical component here, so it should go down of some sort. All right. We're going to start with conservation momentum. P total momentum initial equals total momentum final. So that would be P I plus PBI equals PAB. They're joined together. Final. So if I was to write all that out, we end up with MAVAI plus MBVBI equals the total momentum would be the total mass, MA plus MB times VBF. All right. So you rearrange all this and you solve for velocity. For that is the goal, to get the speed and direction. So that's basically velocity. So V A B final equals M A B A I plus M B I and divided by the total M A plus M. All right, so up here I'm going to do this in component form, starting with the x component. Vectors can separate into x and y component. The mass was 20, the velocity was 2. So, and I'm just taking this formula and breaking it x and y directions. So I'm going to leave it in grams. I could change it to kilograms, but you have grams, 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 all the grams will cancel out. So the units really aren't that critical in this case. So 20 is going to the right at 2 plus 30, the mass of the other piece of clay, going down to the left at 1 times cosine because it's in the x component. And I'm going to do it all the way around. So this is the 0 direction. So 0, 90, 180, add 30, it would be 210. Again, I'm making these vectors in component form. And so that's the top of the equation, then divided by the summation of the two masses. So that'd be 20 plus 30. Do this calculation, you get 0.28. That would be meters per second, because that's what we're solving for, the velocity. I do a very similar equation, same thing as this. Well, not totally same, because we have y components, so let's write this out. So it would be 20, the same mass, but now, because this is going completely to the right, east, it has no y component, so this is times 0 plus 30 times 1 times sine of that angle. Divided by 20 plus 30 or 50. Alright, do all that calculation, you get negative 0.3 per second. So basically we have the x and y components. So let's see, positive x, negative y. So after this collision, we're going this direction. Positive x, negative y. So the net is down and to the right, which could make sense. You got maybe this is going faster. It has more momentum, so that would cause this to go down after they join together. So we need to get the angle, this angle here, at the two sides. This side is 0.28. This side is negative 0.3. So to get the hypotenuse, the net velocity, we'll call V. Pythagorean theorem. Got a right triangle there. So it's going to be 0.28 squared plus 0.3. This is negative, but the negative will drop because it's squared. And we're to be 0.41. Okay, so that would be the velocity, and the only thing left I have to do is get the angle, this angle here. So you have an opposite side and an adjacent side, so I'll do inverse tan. So I guess here, let's see, tan inverse. So then it's going to be negative divided by 0.28. And I get an angle of, inverse tan, negative 0.3 divided by negative 46 degrees. So that means that this is below the horizontal by 7. So 47 degrees, I guess you could say south of east. A little crowded there, sorry about that. But there is our magnitude, and there is our direction, 47 degrees south of east. The next one. All right, billiard ball is shot east at 2 meters per second. Second identical ball is shot west at 1 meter per second. The balls have a glancing collision, not a head-on collision, deflecting the second ball by 90 degrees, sending it north at 1 meter per second. So I'm going to draw the situation. We have bowling ball going east, or not bowling ball going east. The other ball is going west. And then after the collision, the second ball, which we're going to call B, goes this direction. So I can call this V I. This would be V B F. So the net momentum before the collision is definitely in the x-axis. So these two will add up. The total will have to be in the x direction. So this, whatever the other one is, will have to be add up to something in the x direction. So I'm not really sure. That should be down of some sort. So it'll add up to be 0. It couldn't be up because then you have two things going up, and you don't start with any momentum going upward. All right, so conservation momentum, same kind of thing. So P I plus P I equals P A F plus P B F. So let's see, we go x and y direction. So x direction. Momentum is mass times velocity. So in the I direction, you have identical balls. It's key here, so that we don't have to worry about the masses. Everything's identical. So momentum is m times v. So I'm just going to call that m, for the mass of the ball, times its velocity, which is 2. So m times 2 plus the mass of the other ball, identical. So that we'll call that again mass times, and it's shot west, so that would be the negative. We'll consider west as negative, so this would be the negative 1 direction. And afterwards, this, we don't know anything about the 8 ball. That's unknown. It's going to have to be down some way, but we don't know what it is. So just call that M F. But the other object, the other ball, goes vertically, so consider the x direction has no x components. This is up and down, so this is 0. So we can complete this pretty straightforward. M times 2, this would be M times 1. We got M times VF. M's are on both sides, they cancel. So 1 equals F. Do the same in the y direction. So it's going to be, they're both going horizontally, so they have no component in the y direction. So we just can go m times 0 plus m times 0. We again don't know anything about this. We don't know its direction, so we'll just call it the mass of it times VF. By the way, I should put the x component here. This will be the y component. Plus the other one, which goes straight up. We know its mass is the same. It doesn't break apart. So it would be m. And then whatever velocity, which it says sending it north at 1.41. So this is 1, 1. So this is all 0. M times 0, m times 0. So you got 0 equals m d f y plus 1.41 m. M should cancel this over, so we got negative 1.41 equals f y. All right, so we got our VF AFX and VFY. So again, we have basically you have an x component in this direction, which is the 1. The y component downward is negative, so something like that. So the hypotenuse is what our net velocity. So we're going to use the Pythagorean theorem. So 1 squared plus negative 1.41 squared and I ended up with 1.7 meters per second. And then I solve for the angle. So it's inverse tan of the 2 of 10, 1. Negative 1.41 over 1. Solve for the angle, we get 50, negative 54 degrees because you have the negative there. Or we could say 54.7. I think they wanted to solve the east, so it's 50 because it's below, so it's going to be 54.7 S of. There you go. So there's your angle, there's your velocity. That's the answer.